Hello and welcome to Vodcast 4.2. This vodcast is focused on glacial erosion and deposition, and I'm really excited that I get to make some zoology connections when describing these features. Before going into glacial erosion and deposition, I'd like to take an expanded look on how glaciers move, because there are some very important concepts that underlie glacial movement. Glaciers can move in two ways. The first way is plastic flow deep within the ice. Keep in mind that deep within the glacier, the ice is under incredible pressure due to the weight of the ice on top of it. That highly pressurized ice can flow, almost like melted plastic would flow. The second way that glaciers move is as the entire body of ice slips along the surface. Both movements described, the plastic flow and the slipping along the surface, are happening simultaneously. Now we know that plastic flow occurs deep within the glacier, far below its surface, but what's happening in the uppermost layer of the glacier? It's important to note that the pressure near the top of the glacier is not nearly as intense as the pressure deep within the glacier. The ice near the top of the glacier will behave as a brittle solid, and as plastic flow is occurring deep within the glacier, and as the glacier slips along the ground, that top layer of ice can be subjected to some really strong tension forces. When that happens, the top layers in the ice can crack, and those cracks in the top layer that form due to the movement of the glacier are called crevasses. They can be over 150 feet deep, so you would not want to fall into one of those. These crevasses in the top portion of the glacier can make travel across glaciers extremely dangerous. Okay, let me overview some glacial erosion features for you. In the illustration shown, the bottom picture shows what the terrain may look like today. But if we go back in time, back to when the glacier dominated this landscape, we would see the middle picture. The first thing I want to discuss is the glacial trough, and it's that really deep bowl-shaped region that's carved out by the main glacier. The glacial trough is often part of some spectacular mountain valleys, and the glacial trough will typically occupy the lowest parts of the region. The next feature I want to highlight are the cirques, and the cirques are hollowed out bowl-shaped depressions that have walls on three sides, with the fourth side opening to the down valley side. The picture on the right is an excellent example of a cirque, and it nicely illustrates the characteristic three-sided bowl shape we see when we see cirques. The next feature I'd like to overview is arate, a word that I really enjoy saying. Arate are sharp, rugged mountain ridges produced by glaciation. I think they kind of look like the back of a stegosaurus, but the knife blade shape that they have at their tops is caused predominantly by glacial erosion. A related erosional feature is the horn. A horn is a pyramid-shaped mountain peak, and here's a really dramatic picture of a horn. This picture shows a really well-developed, pyramid-shaped peak. And then the last feature I'd like to overview regarding glacial erosion is the hanging valley. Hanging valleys will typically occur at the very end of cirques, where the cirque opens to the glacial trough. And because the cirque is typically elevated high above the glacial trough, hanging valleys are notorious for producing some awesome waterfalls. And you can see one of those waterfalls in the image shown on this slide. I'd like to overview glacial drift before I get into glacial deposition. As glaciers move, they pick up material. And due to the immense power of glaciers, they can carry both very large and very small materials over very long distances. Now, when the glacier melts, all of the materials that it picked up will be deposited. By definition, glacial drift is any sediment of glacial origin. Glacial till is an unsorted mixture of many different sediment sizes. And I want you to take a really close look at this picture shown on the slide. You may see this picture on quizzes or tests. And this picture shows a piece of glacial till that went along for a ride, courtesy of a glacier. Notice all the scratches in this rock. And those scratches were caused by the rock being dragged along by the glacier as it moved. Our third consideration on this slide is glacial erratics. And due to the immense size of glaciers, they can move things as large as boulders, extremely long distances. If you find a boulder in a region where the composition of the boulder does not match the bedrock found below, there's a really good chance that boulder was placed there by a glacier. Okay, now let me overview some glacial deposition features. The first thing I'd like to highlight is the end moraine, shown to the right side of this image. The end moraine is a very large ridge of till that accumulates at the terminus of a glacier. You can think of the terminus as the furthest the glacier made it before it started to melt and retreat. Another depositional feature I'd like to highlight is the drumlin field, which is shown towards the top of this image. Drumlins are asymmetrical till mounds, and I think that they resemble whales in the ocean. Drumlins will typically be perpendicular to the end moraine, and they're thought to form when glaciers move over previously deposited drift and reshape it. Another depositional feature shown in this image are kettle lakes. Kettle lakes are formed when a block of stagnant ice gets caught and buried in drift. That buried ice will eventually melt, and when it does, it will leave a pit of water in the glacial sediment. The final depositional feature I'd like to highlight in this image are eskers. Eskers are long, snake-like till ridges, and they're formed by streams flowing within tunnels inside the glacier or from streams beneath the ice. Eskers will typically occur near the terminus of a glacier, and the terminus of this glacier shown in this image is its leading edge. Although there are many erosional and depositional features to consider, I didn't want this video to be 30 minutes. So for the sake of quizzes and tests, what I recommend you do is make a list of erosional features and depositional features, make sure you know which ones are which, and then jot down a definition for each term that we've gone over in this video podcast. Our final consideration in this video podcast is moraines. Specifically, I'd like to focus on the end moraine, because the formation of end moraines is very dynamic. If you take a look at this picture, the end moraine is the one furthest from the current glacial position. The end moraine occurs at position D. It's the furthest out moraine that this glacier was capable of making. End moraines tend to be very big because at the furthest advancement of the glacier, melting will start to occur. And when melting is occurring at position D, all of the glacial drift that the glacier contains will be deposited at that location. Now something really interesting is occurring at the end moraine. As the terminus continues to melt and deposit glacial drift, keep in mind that the glacier is still moving. It's flowing forward. So the position of the end moraine can stay at relative equilibrium for a while. And as the glacier moves to that position, the terminus will continue to melt, dropping more and more glacial drift onto the pile. Now there are many varieties of moraines. There are medial moraines, lateral moraines, end moraines, which has been the focus of our conversation on this slide. But generally speaking, just know that moraines are layers or ridges of deposited till, and an end moraine indicates the furthest terminus advancement for a glacier. Okay, that's the conclusion of this video podcast. At this point, we're going to shift gears a little bit, and we're now going to consider some arid landscapes.